Hello guys. In this lecture we are studying the derivations of pressure. Okay. Now see here. Let us consider a perfectly let us consider a fixed mass. Let us consider a fixed mass of a perfect gas is enclosed in a cubical vessel. Enclosed in a cubical vessel. Okay. The cubical vessel, the each side of cubical vessel having length L. Okay. Now the walls of these cubes are perfectly elastic. Okay. In previous lecture we have already studied the assumptions of gases. Okay. So the small tiny particles are known as molecules. So see here, the molecules of a gas are moving in all possible directions with all possible velocities. These small tiny particles are moving in all possible directions with all possible velocities. Okay. Now see here, let capital N be the number of gas molecules. Okay. Let small m be the mass of each molecule. So the total mass of a gas, capital M, is equal to number of molecules into mass of each molecule. So capital M is equal to N into M. So capital M is the total mass of a gas. A is the area of each face. So each face of cubical vessel is a square. So area of square is side square. So A is equal to L square. So area of each face. A is the area of each face. Now V is equal to L cube. That means V is the volume of cubical vessel. V is the volume of cubical vessel. And rho is the density. So the formula for density is equal to mass upon volume. Okay. So capital M is equal to N into M upon volume L cube. So Nm upon L cube is the density of the gas. Okay. Now see here. Let C1 bar, C2 bar, Cn bar be the velocities of molecules. Okay. So each velocity can be resolved into components parallel to the three coordinate axis. Okay. Each velocity can be resolved into three components. Okay. These three components are parallel to the three coordinate axis. Okay. Now see here, let U1 bar, V1 bar and W1 bar be the coordinates or the components of velocity V2 bar and W2 bar be the components of C2 bar. Be the components of velocity C2 bar along XYZ axis respectively. Similarly, UN bar, VN bar and WN bar be the components of velocity Cn bar along x, y and z axis. Then C1 bar, then C1 square is equal to U1 square plus V1 square plus W1 square. Similarly, C2 square is equal to U2 square plus V2 square plus Wn square. Similarly, Cn square is equal to Un square plus Vn square plus Wn square. Always equation number 1. Okay. So these are the velocities. Now here, now let us consider a molecule of mass m, which is moving with velocity c1 bar. Okay, c1 bar along. Let us consider a molecule m. Let us consider a molecule of mass m is moving with velocity c1. Okay, towards the wall PQRS. This is the molecule of mass m moving with velocity c1, towards the wall PQRS. It moves with velocity u1 bar along x-axis. It moves with velocity u1 bar along x-axis. Okay. Now the initial momentum. Of the molecule. Now the initial momentum of molecule is equal to, formula for momentum is mass into velocity. So mass of that molecule is m and moving along x-axis, that means the velocity is u1. So m u1. Okay. Now if the molecule is collides on the wall PQRS. Okay. Now see here firstly, let us consider a molecule of mass m. Okay. This molecule is moving along x-axis towards wall PQRS. Okay. So the initial momentum of the molecule is m into u1. Okay. This molecule minus mu. Why minus? Because that molecule is rebound when it collides on the wall PQRS. Okay, then that molecule is rebound in along x direction. That means the velocity is negative because that velocity is in opposite direction. So the momentum after collision is minus mu. Okay, now we have to find the change in momentum. Now we have to find the change in momentum. Change in momentum. So change in momentum is equal to momentum after collision minus initial momentum. Okay, so we get momentum after collision. Momentum of after collision is minus mu1 minus initial momentum mu1. So we get the change in momentum is equal to minus 2 mu1. Minus 2 mu1 is the change in momentum. Okay, so that negative sign shows that molecule has lost momentum during collision. This negative sign indicates that the molecule lost momentum during collision. Since momentum is conserved, so the change in momentum, momentum is conserved, so the change in momentum which is equal to 2 mu. Okay, because the negative sign indicates that the loss of momentum during collision. Okay, so the momentum is conserved. Okay, so the change in momentum is equal to 2 mu. Okay, so now see the distance traveled by molecule. The distance traveled by this molecule between two successive collisions. Now the molecule starts from here. So firstly, that molecule is collides on the wall PQRS. Okay, then after the collision or after that molecule is collides on the wall PQRS, then that molecule is rebounds and collides on the wall P dash, Q dash, R dash and S dash. So that molecule covers the distance L plus L. That means the distance traveled by the molecule is 2L. The distance traveled by molecule is 2L. Okay, now we have to find the time. Okay, now see here, according to the formula of speed is equal to distance upon time. Okay, now time is equal to distance upon speed. Okay, so the distance covered by the molecule is 2L and the speed is along by according to the Newton's second law of motion. So by using Newton's second law of motion. So we get F1 is equal to rate of change of momentum. So change in momentum upon time. So change in momentum, that is 2mu upon time. Time is equal to 2L upon u. So we get 2 to get cancelled, and u square upon L. So F1 is equal to m change in momentum and u1 square, calling it m u1 square upon L, calling it equation number 1. So similarly F2 is equal to n u2 square upon n. So similarly Fn is equal to n un square upon n. Okay. So these are the forces are calculated by using Newton's second law of motion. Okay. Now see here. Before I erase this, I can explain again. Let us consider a cubical vessel. In this cubical vessel, we enclose a gas. Okay. Let n be the number of gas molecules, small m be the mass of each molecule, capital M be the total mass, A be the area, V be the volume, rho is the density. Okay. So C1 bar, C2 bar, Cn bar be the velocities of the molecules. So these velocities can be resolved into 3 components. So U1 bar, V1 bar, W1 bar be the components of velocity, C1 bar along XYZ axis. Similarly, U2 bar, V2 bar, W2 bar be the velocities, be the components of velocity C2 bar. Okay, so C1 square is equal to this. Similarly, we can calculate. Now let us consider a molecule of mass m which is moving along x-axis with velocity u1. This molecule is moving towards the wall PQRS. When that molecule is moving towards the wall PQRS, then the initial momentum of the molecule is mass into velocity, that is m into u1. When that molecule is rebound or collide the wall PQRS, then that molecule is rebound in opposite direction. So the momentum after collision is minus mu. So to find the change in momentum, final means after collision minus initial, so we get minus 2 mu minus 2 and u1. This negative sign indicates that the loss of momentum. Okay, so the momentum is conserved, so change in momentum is equal to 2 m u1. Okay, so the distance traveled by the molecule is equal to 2l. Okay, so by using the formula speed is equal to distance upon time, therefore time is equal to distance upon speed. Substituting the values 2l upon u1, so this is the time. Now we want to find the force exerted by the molecules on the wall. So F1, this force can be calculated by using Newton's second law of motion, the rate of change of momentum. Okay, so F1 is equal to change in momentum upon time. So substituting the values, we get in F1 is equal to m u1 square we have to calculate in the resultant force. Okay, so this resultant force can be calculated. So the resultant force Fx, so the resultant force Fx mean, so Fx is equal to F1 plus F2 plus and so on Fn. Okay, so now substituting the values of F1, F2 and Fn. F1, F2 and Fn. So substituting the values, so we get F1, the value of F1 is mu1 square upon n plus mu2 square upon n plus and so on plus mun square upon n. Okay, so m upon n is common in each term, so taking outside, so m upon n into u1 square plus u2 square plus and so on un square. This is the Fx force along x-axis. So similarly, we calculated Fy along y-axis, that is m upon l into v1 square plus v2 square plus and so on vn square. Similarly, F same is equal to m upon l into w1 square plus w2 square plus and so on wn square. These are the forces along x, y and z axis. So now according to the formula of pressure, okay, so pressure is equal to force upon area. Force upon area. So let Px be the pressure acting on the wall, perpendicular to x-axis. So the Px is equal to Fx upon A. Okay, so A is equal to L square area. That means P is equal to Fx upon L square. So substituting the value of Fx. Okay, so we get Px is equal to m upon L cube or m upon L into 1 upon L square, that is L cube into u1 square plus u2 square plus and so on un square. Okay, so this is the pressure along x-axis. Similarly, the Py pressure along y-axis, that is m upon L cube. Wait, let's see this. So m upon L cube into v1 square plus v2 square plus and so on vn square. Similarly, Pz is equal to m upon L cube into w1 square plus w2 square plus and so on wn square. This is the pressure along y-axis. Okay. Now, as the pressure exerted by the gas molecule is same in all directions, what? The pressure exerted by a gas molecule is same in all directions. Okay, so the Px is equal to Py is equal to Pz is equal to P. Okay, so we get Px plus Py plus Pz is equal to 3P. Okay, therefore P is equal to this 3 get here. So P is equal to Px plus Py plus Pz upon 3. Okay, so now substituting the value of Px, Py and Pz. Okay, so we get here P is equal to 1 upon 3 into Px means m upon L cube, m upon L cube into u1 square plus u2 square plus and so on un square plus Py, that means m upon L cube into v1 square plus v2 square plus and so on vn square plus pz m upon L cube into w1 square plus w2 square plus and so on wn square. Okay, now m upon L is common. Okay, so taking outside, okay, so we get m 1 by 3 into m upon L cube into u1 square plus u2 square plus and so on un square plus v1 square plus v2 square plus and so on vn square plus w1 square plus w2 square plus and so on wn square. Okay, now see here L cube means L cube is the volume, so we get 1 upon 3 into m upon v into, we have already known u1 square plus u2 square plus and so on un square, that is equal to c1 square plus v1 square plus v2 square plus and so on. So we get c2 square plus and so on cn square. Okay, so cn square. Okay, now according to the definition of the root mean square velocity, density is equal to mass upon volume. So this can be written as P is equal to 1 by 3 into rho CIS square. This is the formula